Section 7.5, you put together all the stuff that you've learned and you began to use this to solve trigonometric equations. So you're using the trig identities and you're using algebra. If it asks you for the principal values, that's when the variables are restricted to two adjacent quadrants. This is very similar to when we had the limited domain for the capital letter, the capital S, or the capital A for the anti-sign. Okay, so the sine and the tangent are limited to the first and the fourth, or between negative 90 and 90. Sometimes they do it in radians, sometimes they do it in degrees. The cosine of x is limited to the first and the second, so that's between the 0 and the 180. Okay, so for instance, let's say that they asked you to solve these problems in degrees, but they ask it for the principal values. So you look at this and you go, okay, algebraically, what can I do? Well, you can factor out the cosine of x. So I've got the cosine of x times, when I factored it out, I get sine of x minus 1/2 equals 0. Then I set both of those equal to 0. So the cosine of x is equal to 0. The sine of x minus 1/2 is equal to 0. Well, then when I solve this, I get the sine of x equals 1/2. So I am looking in degrees for where the cosine, the principal value of the cosine is 0. Well, remember that's between the 0 and the 180 degrees because that's the first and second quadrant for principal values. So that's going to give you an answer of 90 degrees. For the sine, you have the first and the fourth quadrant, but you realize the sine is not positive in the fourth quadrant. So we limit it to the first quadrant, and where the sine is equal to 1/2 would be 30 degrees. Okay, you can use your unit circles on those. Coming over here, you notice you have a trinomial, so the very first thing you're going to try is to unfoil it. So this times this is going to have to give me that. So I have a 2 and a sine of x and a sine of x. And then I have a minus 1 and a positive 1 because that's going to give me, when I do outside, a positive 2 times the sine of x. When I do inside, a negative sine of x, which when I add those together gives me a positive sine of x. So then I set those two equal to 0. 2 times the sine of x minus 1 equals 0. Sine of x plus 1 equals 0. Okay, so then I solve. So I'm going to add a 1, and then I'm going to divide by the 2. So I have a sine of x is equal to 1/2. I already did that. I know that the sine of the principal sine of x equals 1/2 is at 30 degrees because I'm limited to the first and the fourth quadrant with a sine. This says the sine of x equals negative 1/2. Well, that of course is at the bottom of your unit circle, but I'm not allowed to go through the second and third quadrant, so I need to speak it as negative 90 degrees. Okay, that's the way that I get to, if you will, down here without going through those two. So I need to get to that spot, so I go down 90 degrees. So those are your two answers here. Sometimes you have more than two answers. Okay, these are similar examples but with different instructions, because if you notice on this one it says I'm solving for between 0 and 2 pi. Well, if that says pi, I know I want my answer in radians, and this time I'm not restricted to the principal values. I'm restricted to one time around the circle. Now if you notice here, you've got cosines on this side and you've got sines on this side. So I'm going to switch them all to cosines, and the way that I'm going to do that is think about my Pythagorean identity that says the cosine squared theta plus the sine squared theta is equal to 1. So the sine squared theta is equal to 1 minus the cosine squared, or in this case x. And I'm going to continue to bring this down. Okay, I hope you can see this in pencil. So now I want to take everything to one side. The 1's go away when I subtract it. I'm going to add the cosine, so I'm going to get 2 times the cosine squared x minus cosine of x equals 0. What I can do is I can factor out a cosine of x. So I'm left with 2 cosine of x minus 1 equals 0. I set them both equal to 0. Okay, when I solve here, I'm looking for, in radians, wherever the cosine is equal to 0, all the way around the unit circle. So that's at pi over 2, and that would be at 3 pi over 2. Those both are going to give me an answer of 0. This is the cosine is equal to 1/2. Now that's going to be in the first and the fourth quadrant. So that's at pi over 3, which is in the first quadrant, and then it's at, if you look at your unit circle, 10 pi over 6, which is equal to 5 pi over 3. So I have 4 answers here. All right, this one's very similar, okay, except for now I have sines here and I have a cosine here. So I'm going to change the cosine. So this is going to be 1 minus the sine squared x. Again, it's from that Pythagorean identity. When I add the sine squared x, I get 2 sine squared x minus the sine of x. And when I subtract the 1, those go away. So it's very similar to this one over here. I'm going to factor out the sine of x. And I'm going to get 2 times the sine of x minus 1 equals 0. I set them both equal to 0. And when I solve, I get the sine of x is equal to 1/2. Okay, so I'm looking for, one time around the circle in radians, where the sine is equal to 0. We're talking 0, we're talking pi. I'm looking for where the sine is equal to 1/2. Now that's going to be, and it's positive, so it's going to be in the first and the second quadrant. In the first quadrant, it's at pi over 6, and at the second quadrant, it's at 5 pi over 6 when you look at your unit circle. All right, now this one has even different instructions. This one says, solve for all real values of x. So when you finish, you're going to have to put it in like an equation that's going to take into consideration no matter how many times you go around the circle. So this one, I have a secant and I have a tangent. I'm going to change this to tangent using my Pythagorean identity. I know the secant is equal to 1 plus the tangent squared x minus the tangent fourth of x is equal to -1. I'm going to do distributive property, so I have 2 plus 2 times the tangent squared x minus the tangent of the fourth of x equals -1. I'm going to take it all to one side because I'm going to take it to the right hand side because I want this to be positive. And when I do that, I'm going to get this, the tangent fourth of x minus 2 times the tangent squared of x minus 3 equals 0. That's a trinomial. I'm going to unfoil it. So I have the tangent squared x minus 3 is how it would have to work out. Tangent squared x plus 1 is equal to 0. When I set these equal to 0, I have a tangent squared x is equal to 3. I'm going to have to take the square root of both sides, so I have a tangent of x is equal to plus or minus the square root of 3. Well, that is going to be at your pi over 3. So if you're looking at your unit circle, Okay, I am right there, which is pi over 3. But then I'm also right here, because I don't care if it's positive or negative. It would be at my 60-degree reference angle from my x-axis. So that's pi apart. So I can go pi times k. So every pi times k, I'd be here, 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 here. Okay, so that's one spot where I'm going to get that. The other spot that I'm going to get that is going to be, if you will, at that location. Okay, so this is 2 pi over 3, or 4 pi over 6, plus pi units, because it's going to be that way down here too, because that's the same reference angle. All of these have a reference angle of 60, or pi over 3. So then I also have 2 pi over 3 plus pi times k. So both of these are answers for this side. Then I come over here. I have the tangent squared x is equal to -1. Well, I can't take the square root of a -1, so the answer there is empty set. So the only two answers are here and here. All right, let's do this one. This, you have 4 terms, so you're actually going to do grouping, if you remember that. So I look to see what I can factor out here. I can factor out a 2 sine of x, which is going to give me 2 times the cosine of x minus 1. And I can factor out here, I can factor out, I want to change the sign here, so let's factor out a negative square root of 3, which is going to leave me 2 times the cosine of x minus 1 equals 0. If you remember how to do this, you take the one that they have in common, and that goes in one parenthesis, and then you take the part that's on the outside, and that goes in the other parenthesis. Set them equal to 0. So I have 2 times the cosine of x minus 1 equals 0, and I have 2 times the sine of x minus the square root of 3 equals 0. When I solve this, I have the cosine of x is equal to 1/2. When I solve this one, I have the sine of x is equal to the square root of 3 over 2. Now remember, you're looking for all real values and you want it in radians. So where the cosine is equal to 1/2 is at pi over 3. That's your 60-degree mark. And then every time around the circle, because I need the 1/2 to be positive, so it needs to be at, that's every time I hit the first quadrant. This is in the fourth quadrant. No. Yeah, this is in the fourth quadrant. It would be 5 pi over 3, which is 10 pi over 6. Okay, so 5 pi over 3. And then every time I hit that, going around the circle. Okay, so those are answers there, because here it didn't matter whether it was positive or negative. Here it has to be positive, so it's in the first quadrant and it's in the fourth quadrant. Okay, the sine is positive, so this would be in the second quadrant. So the sine is the square root of 3 over 2 at pi over 3 plus every time around the circle. And at 5 pi, or at 2 pi over 3, I'll get that mixed up there, which is in the second quadrant. That's another spot that you're going to find the sine is the square root of 3 over 2, plus every time around the circle. Okay, that's for the most part it, except for inequalities. So we're going to do a few more where you actually can see more examples. This one says solve for principal values and express in degrees. So subtracting the 1, so I end up with the sine of x is equal to -1/2. Well, for the sine, I'm talking first and fourth quadrant. Well, the sine is not negative in the first quadrant, so I'm limited to the fourth quadrant, but again, I can't go through the second and the third, so x is going to have to equal -pi over 6, or, because it says express in degrees, negative 30 degrees. Okay, this one, the cosine of x is equal to the square root of 3 over 2. Cosine is limited to first and second quadrant. In the second quadrant it would be negative. This is positive, so I only need to worry about the first quadrant. And the cosine is positive, and the square root of 3 over 2 at 30 degrees. Again, you're looking at your unit circle to get these. Okay, this one says solve between 0 and 360. Because it's presented in degrees, I want the answer in degrees. So what I'm going to do is I'm going to change this cotangent to sines and cosines. So I have the sine of x times the cosine of x over the sine of x, because that's what cotangent is equal to the square root of 3 over 2. Those are equal to 1. So I'm looking where the cosine of x is equal to the square root of 3 over 2. Not for the principal values, but for one time around the circle. So you're talking the first quadrant and you're talking the fourth quadrant. So it's 30 degrees and it's 330 degrees. I'm allowed to go through my second and third quadrant here. That's why it's different than when we're talking about principal values. This one I'm going to convert using one of my identities. This is because this is a sine, I'm going to change this to 1 minus the 2 times the sine squared x is equal to sine squared x minus 2. I'm going to need to bring this all to one side, so I'm going to add the sine squared x, which is going to give me 3 sine squared x. I'm going to subtract the 1, which is going to give me a negative 3. And if you look here, I can factor out a 3, so I have sine squared x minus 1. Setting the 3 equal to 0 does nothing, so I'm going to set the sine squared x minus 1 equals 0, and I'm going to get sine squared x equals 1. The square root is going to give me plus or minus 1, because the square root of 1 is positive or negative 1. So again, I'm talking about one time around the circle, so I'm talking 90 degrees and I'm talking 270 degrees. Those are the two locations where the sign is either positive 1 or negative 1. All right, you're going to do the same thing here, except for now we're doing it in radians, and it's still one time around the circle. So when I solve here, I get the tangent squared x is equal to 1/3. So when I take the square root of it, I have the tangent of x is equal to plus or minus 1 over the square root of 3. Well, the locations for that, because it doesn't matter whether it's positive or negative, but it is all of my 30-degree reference angles. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 if you go all the way around your unit circle. This one, I'm going to bring it all to one side, so let's do 2 on the sine squared x minus 5 sine x minus 3 equals 0. And I'm going to unfoil this or factor it. 2 times the sine of x plus 1, and the sine of x minus 3 will get you that when you use FOIL on it. So when I solve this, I have the sine of x is equal to negative 1/2, and the sine of x is equal to 3. Well, nowhere is the sine of x equal to 3 on your unit circle, so that's empty set. This one is at 7 pi over 6, which is in your third quadrant, and this is in my fourth quadrant. Okay, because that's listed in radians, this needs to be in radians. Okay, now this is one where you have to come up with the equation because it says solve for all real values in x. So this one's a little bit different. I'm going to take, this is a 2x, so I'm going to change this to 2 times the sine squared x and cosine squared x. That's an identity here of the double angle, plus the cosine squared x is equal to 0. I'm going to factor out the cosine squared x. So 2 times the sine squared x plus 1 equals 0. Cosine squared x equals 0. And 2 times the sine squared x plus 1 equals 0. This one is going to give me that, but when I take the square root, I can't take the square root of a negative, so that's undefined. Don't have to worry about that. The spot where the cosine of x is equal to 0 is at pi over 2, but it's also at the bottom, which is going to be your 3 pi over 2, so it's every pi units, bottom, top, bottom, top. So that's the equation that will get that. This one I'm going to go ahead and factor, so I have the tangent of x plus 1, and I have the tangent of x plus 1. So I only have to solve it in one location, so I have the tangent of x is equal to -1. Well, that is going to be in my second and fourth quadrant. So the first time I get it is at 3 pi over 4, but then it's every pi unit. So every 180 degrees, if you will, which puts it in the second, fourth, second, and fourth. All right, then the last part of this section has to do with inequalities. Inequalities are a little different. I do solve for it. So I have the sine of theta is greater than, I'm sorry about that, -1/2. Well, if I'm looking at my unit circle, I have a sine of 1/2 at here, and I have a sine of 1/2 at here. This is going to be at your 11 pi over 6, and this is going to be at your 7 pi over 6. Well, the area where it's greater than 1/2 is all of this area. Now, I'm going to have to make that in two statements because this is 0 to that. So I can say theta is going to be greater than 0, and it's actually including 0 because it goes past the 0, and it's going to be less than 7 pi over 6. That is going to be all of that area. Then I have to deal with this little spot right here. That is where I did it backwards. Okay, where it's less or greater than 11 pi over 6, which is greater than 11 pi over 6, and it's less than 2 pi. Okay, because that would be all the way around. And those are both less than. The only time that it includes that is going to be right here. Okay, and so therefore I don't need to include it right there. Okay, so that's going to be both spots. This one, this is a little bit hard to understand. Okay, this is just the opposite. This is where I'm asking for where it's less than 1/2. So on my unit circle, now I'm talking this area right here. Well, I can do that in one statement. It's going to be greater, going around the circle, it's greater, you can use phi or you can use theta, it doesn't matter which. It's greater than 7 pi over 6, which is taking me this way, but it's less than 11 pi over 6, which is this way. Hopefully you can see that. Okay, so here you're talking about this area because it's greater than 1/2. Here you're talking about this area because it's less than 1/2. All right, your homework on this, just do the best job you can, is page 459 through 460, 18 through 50 even.